When a wintergreen lifesaver is cracked, the electrons split unevenly, forcing them down in energy level, or putting them into the air. We're able to see the light because it's in the same spectrum of light as lightning is. Just as lightning is, the energy created from breaking a lifesaver is excited nitrogen electrons. Now, it also creates UV radiation. And because it's UV radiation, the energy level is so high that it appears as a faint light, but it's actually not. It's very high on the spectrum. This relates to what we've been learning in class because it explains how principal energy levels work and how electrons figure out where they're going to go, or where they go if they can't figure that out. Now, this is related to UV radiation because the wintergreen molecules absorb the radiation, and once the breakage happens, the splitting of the electrons, this absorption allows it to free itself, and once it's freed, it emits visible blue light. But that only happens when too much energy accumulates, so that's why it is absorbing UV radiation. Now, all of this is related because wintergreen molecules and nitrogen particles and electrons all have the same wavelength and are part of the same spectrum of light. According to the article, all lightning is electrons passing through the air, exciting nitrogen particles and causing the emission of light. Whereas triboluminescence is just lightning on a small scale. Most other sugar candies aren't triboluminescent, however, because they contain crystals that naturally separate the electrons and charges, and they're also made of artificial sugars, which is what causes the natural separation. So, to recap, lightning is the excitement of nitrogen particles, triboluminescence is the same exact thing, on a small scale. Artificial sugars won't create triboluminescence because they need to be natural, otherwise they will naturally separate the charges, which would call for this to not work because the electrons have to be unevenly distributed, which causes them to go into the air, emitting light. And the emission is from the absorption of UV radiation, which then collides with the nitrogen particles and releases the light, the visible blue light.